So in chapter 1, chapter 2, we talk about the statistics, and we have two goals, okay, in this course. We'll learn the descriptive statistics and the inferential statistics. We use descriptive statistic to describe a data set, right, or to gather information from a data set. That is the part of descriptive statistics. And in the inferential statistics, we have a sample. We use the sample information to generalize the population or to make a decision for the population, okay? So inferential and the descriptive statistics are the two parts. Now in chapter 3, we have probability. Now in the inferential statistics, what did we do? We use our sample information to make a generalization, right? We didn't do a lot of example of that kind. We will do that after, like from chapter 4 onwards, we will make more generalization, we will make more estimation using a sample, okay? So we had a sample and we use that sample information to generalize our population, okay? That was what we did in chapter 2. And now here in chapter 3, we will consider we are given a population, okay, and we will find the chances of we will find the chances of getting the sample from a population. So in statistics, we had a sample. We use that sample to generalize population, okay. Now here we will assume that population is none, okay. We will consider population is none to us. Okay, and from that we will find the chances of getting a sample from that population. Okay, so probability and statistics, these two are reverse of each other. So statistics is you have a sample, we use the sample to generalize population. In the probability, we have a population, okay, we will consider we know everything about population, okay. And from that, we will find the chances of getting different sample, okay? So probability and the statistics are reverse of each other, okay? Now, in this section 3.1, we will introduce the very basic concept here, okay? We'll start by defining the experiment. You all have played the dice, right? So when we throw a dice, how many outcomes can we see in one throw? When you have a dice and you throw the dice, now how many outcome do we see in one throw? Is one outcome, right? Now is there any way that we can be sure of what outcomes we're gonna have? We don't know what exactly outcomes can we see from that throw, right? So here, our experiment is an observation, okay? It's a process, okay, or it's an act. Okay, that leads to a single outcome. Like when you throw a dice, we always get one outcome, right? And that outcome cannot be predicted with certainty. Now, can you predict getting 5 in a single throw of dice? That's the 1/6, right? Now, that's not the 100%. That does not mean that we are certain or we are 100% sure that we get 5 on a one throw, right? So this process or this act is the experiment, okay? So experiment, it always leads us to a single outcome, okay? And we cannot predict, okay? We don't know whether that outcome occurs or not, okay? We are not 100% sure on getting that single outcome. Now, can you think of another experiment where we get one outcome and we are uncertain of that one outcome? Can you think of like next example of an experiment? Right, so tossing a coin. So when we toss a coin, we always get one outcome, okay? We might get head or tail, but it's always gonna be one, right? And we are not certain, okay? We can't make a prediction which head or tail we get during that experiment. Okay. Similarly, if I pick one student from this classroom, okay, so for example, I'm picking one student from this classroom. Now the outcome I get is 1, and we are not certain on which students gonna be picked, right? So this is the experiment. So experiment is the process, or it's an act of an observation, okay? And we always need an experiment, and from an experiment we always get a single outcome. The next here is that sample point. Now sample point is the most basic outcome of an experiment. So you think we have an experiment. Let's take an experiment of throwing a dice, okay? And when we throw a dice, what are the basic possibility that we can see? So what are the outcome that we can see from that experiment? We can get 1, 2, 3, 4, 5, or 6, right? So this 1, 2, 3, 4, 5, 6 are the sample point for that experiment. Okay, the very basic outcome for this experiment is 1, 2, 3, 4, 5, 6, and those 1, 2, 3, 4, 5, 6 are the sample point. Okay. Now, if we are tossing a coin, so what are the possibility? The outcomes are head or tail, right? So head, tail are the 2 sample points. So when we throw a dice, there are 6 sample points, 1, 2, 3, 4, 5, 6. When we toss a coin, there are 2 sample points. Okay, so sample point are the very basic outcome of the experiment. Now let's take an example. So now we have 2 coins are tossed and their faces are recorded. List all the sample points for this experiment. Okay. Now what is the experiment here? So in this example, so 2 coins are tossed and their faces are recorded. We are listing every sample point for this experiment. What is the experiment here? Tossing a coin, right? So we are tossing a coin. So tossing a coin is an experiment. Now, so here, so when we toss a single coin, so let me take, we have a coin here, okay. So when you toss a coin, first coin, okay, so we are tossing 2 coin. So when you toss first coin, what are the outcomes that you will see from that first coin? We might get head, okay, right? Or we might get tail. Okay, we have first coin. And when we toss first coin, there is the possibility that we can see head, or we also have the possibility to get tail. Okay, now when you toss second coin, okay, let's take, we have head from our first coin. Now what are the possible, or what are the outcomes that you will see in the second coin? Head or tail, right? So in first coin we fix that we get tail. Okay, now in the second coin we might get head or we might get tail, right? So this is for the second coin. Now instead of getting head in the first coin, if we had tail on our first coin, now what are the outcomes for the second coin? It's going to be head or tail, right? So we might get head or tail. Okay, so there is the possibility that we might see head first and head second. So our sample point is head. Okay, first coin head, second coin head. Or we might get head on our first toss, okay, but tail on our second toss. That is head first, tail second. This is our next sample point. The next case we might have is we might get a tail on our first toss and head in our second toss. So that is tail first, head second. or we might get tail in the first coin and tail in the second coin. So tail first, tail second. Okay, so here the possible outcomes are we might get head, we might get head, tail, tail, head, or tail, tail. And these are the sample point for this experiment. Okay, and we use this tree diagram, okay, or you can also use the table. Tree diagram, it really help us to list the sample points. Okay, now does anyone have any question here? Now let's collect the sample point when we toss a 3 coin. Okay, let's see what happens, like what are the possible outcomes. Okay, so let me start from scratch. So we have a coin, right? We tossed first coin, we might get head or tail. Now second coin, so this is for the first coin. Okay, from first coin we might get head or tail. Now let's toss second coin, and when we toss second coin, let's say we have head in the first, so this head in the first we might get head or tail. Okay, if you have a tail in the first coin, second coin might be head or tail. Now let's toss third coin. Okay, so if we toss third coin, if we have a head in the first, head in the second, then third might be head or tail, right? So we might get head in the first, tail in the second, third can be head or tail. So if you get tail in the first, head in the second, third can be head or tail. If you have tail in the first, tail in the second, then on our third coin we might get head or tail. Okay, so what are the sample point here? So head in the first coin, head in the second coin, head in the third coin. So H. So head first coin, head second coin, head third coin. This is one sample point. Head in the first, head in the second, tail in the third. So H, T. Okay, head first, head second, tail third. Or we might get a head in the first, tail in the second, head in the third. So that is head, tail, head. Or we might get head in the first, tail in the second, tail in the third. So that is head, tail, tail. Let me write down here. We might get tail in the first, head in the second, and head in the third. So that is tail, head, head. We might get tail in the first, head in the second, tail in the third. So that is tail, head, tail. Okay, or we might get tail in the first, tail in the second coin, and head in the third coin. So that is tail, tail, head. We might get tail first coin, tail second coin, tail third coin. So tail, tail, tail. So these 1, 2, 3, 4, 5, 6, 7, 8. So these are the sample point for this experiment, tossing a 3 coin experiment. Okay, so when we toss a 3 coin, these are the outcome that we will see. Okay, and these are the sample point. Okay, does anyone have any question here? Okay, now in the similar way, if you are asked to find the sample point when you toss a 4 coin, you can do it, right? Okay, so our sample point are the basic outcome of the experiment. Now before Venn diagram, let me do the sample space. Sample space is the collection of its sample points. Okay, so we have an experiment. When we do an experiment, we have the outcomes. We have the basic outcome we call sample points. And when you collect all those sample points, that collection is a sample space. Okay, so for our example, we had these 4 sample point. okay, we collect these 4 sample point and we get a sample space. So we use S to represent sample space, and we collect every sample point, okay, as a set. So we have a set here. So we have a head, head, tail, head, tail. So you are collecting every possible sample points, and that is our sample space. So let me call S1 for the sample space for our this experiment, okay, tossing a 3 coin. So let's have a sample space here. So we have a head, tail, tail, head, and tail. So this is our sample space for the experiment tossing a 3 coin. Okay, so sample space is the collection of every sample points, and this is one of the way, using a set notation is one of the way to represent our sample space. And we can also have a graphical method to represent a sample space, which we call a Venn diagram. Okay, so we use Venn diagram to represent this sample space graphically. Okay, and you can draw Venn diagram a close picture. Okay, it can be a circle or a rectangle or a square. Okay, so you can use a circle or you can use a rectangle, it really doesn't matter. So let's draw a enclosed surface. So this is our sample space. Okay, or you can use a circle, and inside this enclosed space we use a dot, okay, to represent each sample point. Okay, now let's draw a Venn diagram for this one. So how many sample points we have? 4, right? So we have a 4 dot here, and you can just label each dot. So let's say this is head, this is head, tail, this is tail, head, and this is tail. Okay, and this is the graphical representation of a sample space. Use a circle or a rectangle to represent that sample space. Okay, and inside that sample space we use a dot for each sample point. Okay, and make sure to label your sample point. If we are drawing a Venn diagram for our, okay, let's draw a Venn diagram for throwing a dice. Okay, so let me use circle here, and let me call my sample space is S. So how many sample points we will have when we throw a dice? 6, right? So we have 1, 2, 3, 4, 5, 6. So let's say this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Okay, this is our Venn diagram for the sample space when we have an experiment of throwing a dice. Okay, we are collecting every possible sample points, okay, in an enclosed diagram, and that is our Venn diagram. Does anyone have any question up to here? Okay, now let's go to the next one. So probability. So here the probability of a sample point. Okay, we will be finding a probability of a sample point, and this probability is always in between 0 and 1. Okay, so whenever you are asked to find the probability, it has to be in between 0 and 1. If you end up getting your probability less than 0 or greater than 1, then you must know there is something wrong. Okay, so probability is a number between 0 and 1, and this probability, it tells us the likelihood that the outcome will occur when the experiment is performed. Okay, so when we have an experiment, we get a different outcome. Okay, and for each outcome we can measure the likelihood. Okay, we can measure the chances of getting that outcome, and that measure is the probability. We use a number between 0 and 1. Okay, so your every probability, the value of probability has to be in between 0 and 1. Okay, so probability is just a number, and this number tells us the chances or the likelihood of getting an outcome from the experiment. Okay, now is it possible for us to have a probability 0? What do you think? Can you think of an experiment where an outcome has a probability 0? Is it possible to have probability 0? Can you think of a situation where the probability of getting that event is 0? What is the probability of getting 8 when you throw a dice? Isn't that 0? Like, it doesn't matter how many times we throw a dice, we never get 8, right? Or like a probability of okay, picking one student, one graduate student from this classroom. What is the probability? Or do we have graduate student? No, right? So it's 0. Okay, so we might get our probability 0. So don't get scared when the probability is 0. Now what about probability equals to 1? So can you think of a case where the probability is equals to 1? What do you think? So what will be the case where probability is 1? But if you throw a dice, the probability of getting 2 is not 1. Think of an experiment or case where probability is exactly equals to 1. Okay, what about the probability of picking one undergraduate student from this classroom? Isn't that 100%? Every one of you, but if I include me, then that may not be 100%, right? But okay, I'm saying I mentioned a student, so obviously it's going to be you. So picking one student, one undergraduate student from this classroom. It doesn't matter whoever I pick, I always end up getting undergraduate student, right? So it means the probability is 100. So I'm certain that I will get one undergraduate student when I pick one student from this classroom. Okay, so probability can be equals to 0. Probability can be equals to 1. Okay, and it is always in between 0 and 1. We can't have a negative probability. We can't have a probability greater than 1. Okay, so during your calculation, if you end up getting negative probability or if you end up getting probability greater than 1, there is always something wrong. Okay, you have to double check your answer. Okay. So probability is just a number, okay, and it tells us the chances of getting an outcome. Okay, now we can also take that number as a relative frequency of occurrence of a sample point, okay, for that experiment. So that probability can be also taken as a relative frequency when you repeat the same experiment for like number of times. Now we have two rules for a probability of a sample point. Okay, let's call Pi is the probability for a sample point I. Okay, so we have a sample point I and its probability is Pi. Okay, is a notation here. So every sample point, okay, the probabilities of every sample point must lie in between 0 and 1. Okay, so we have a sample point and we are trying to find the likelihood of getting that sample point when we do an experiment. That's what we are trying to do here. Okay, and when you calculate the probability of that sample point, it must be in between 0 and 1. Okay, so here our Pi is the probability for a sample point I. So this Pi can be equals to 0. Okay, it can be equals to 1. And it has to be in between 0 and 1. Okay, so it should be between 0 and 1. The next rule is that the probabilities of all these sample points, okay, within a sample space must sum to 1. So when we have an experiment, we don't get one sample point. We might have 2 or we might have 6 or we always get more than one sample point. For each sample point, the probability is in between 0 and 1. And when you add the probabilities of each sample point, the sum has to be always equals to 1. Okay? So the summation of pi is the probability of a sample point. So summation of probabilities of all sample point is always equals to 1. Okay? So here we have 4 sample point, right? We can find, we will learn how to find the probability. So each sample point has its own probability, and when you add the probability of getting head, probability of getting head tail, probability of getting tail head, and probability of getting tail, the sum of probabilities of these 4 outcome has to be always equals to 1. Okay, it's always 1. Okay, now let's do an example here. A fair dice is tossed and up face is observed. If the face is even, you win $1, otherwise you lose $1. What is the probability that you will win? Now here we are throwing a dice, we are tossing a dice, right? Now now let's collect our sample points. Okay, let's have a sample space. So what is the sample point here for this experiment? So when you throw a dice, we get 1, or we might get 1, 2, 3, or 4, 5, or 6. So this is our sample space. Okay, this is the collection of every possible outcomes when we throw a dice. Okay, which we call sample space. Now, if the face is even, now what does it mean by face is even? What do we need to get when we throw a dice? 2, 4, 6, right? So the possible face has to be 2, 4, or 6. Okay, let me call that possible. Let me call that 2, 4, 6 even number as a set A. Okay, so we have 2, 4, 6, and when you throw 2, 4, or 6, you win $1. Okay, and here we are trying to find the probability that we will win. Now, in order to find, okay, so we have this sample point 1. Now, what is the probability that we get 1 when we throw our dice? 1/6, right? So the probability, so this is the probability of getting 1 is 1/6. The probability of getting 2 is, what is the probability of getting 2? 1/6, right? Similarly, the probability of getting 3 is also 1/6. The probability of getting 4 is also 1/6. The probability of getting 5 is also 1/6. And the probability of getting 6 is also 1/6. Okay, we divide the sample point, one sample point, by the total sample points. Okay, the reason we are dividing by 6 here is because we have 6 different sample points. Okay, now if we had an experiment of tossing a coin, our sample space contain head, tail, right? And what is the probability of getting head? Is, let me write P of H. This is the probability of getting head, and this is equals to, what is the probability? 1/2, right? So 1, we have 1 head, we get, okay, and divided by total sample points. So we have 1, 2 sample points, so 1/2. Similarly, probability of getting tail. Okay, so we have 1 tail, and the total sample point is 2, so 1/2. And when we add the probability of getting head and probability of getting tail, the sum is 1, right? 1/2 plus 1/2 is 1. So which is the second rule of probability. Now, we want to find the probability of getting even numbers. It means probability of getting 2, or probability of getting 4, probability of getting 6. Okay, so let me write down probability of our set A. Okay, so probability of getting set A is same as probability of getting 2 plus probability of getting 4 plus probability of getting 6. and this is 1/6 plus 1/6 plus 1/6, which is 3/6, and that is 1/2. Okay, so 1/2 means there is a 50% chance that you will win $1. Now, do you risk yourself in this case? Do you play this game? You have a 50% chance to win $1 when you throw a dice. So it's a 50%, right? Okay. Now, does anyone have any question here? Okay. So whenever we have an experiment, you should be able to write down the sample point. Okay. Once you have the sample point, we can find the probability of getting each sample point. Okay. And in order to find the probability of getting each sample point, 1 is always 1 divided by the total sample points. Okay. Let me go back here in this sample space here. So what is the probability of getting tail in the first, tail in the second, tail in the third for this experiment? So when we toss our 3 coin, what is the probability we will get tail, tail, tail? How do we find this? So how many sample point do we have? How many sample point of this type do we have in our space? We only have 1, right? So it's 1 divided by, what is the total number of sample points here? 8. So 1/8 is the probability of getting tail, tail, tail. Now in the similar way, what will be the probability of getting head, head, head? 1/8, right? So what about probability of getting 2 head? Okay, let's find the probability of getting 2 head in this experiment. Now, what are the sample point that contain 2 head? So we have this one. This sample point has a 2 head. This sample point has a 2 head, right? So probability of getting head, head, tail, or head, tail, head, or tail, head, head. Okay, so this is same as, okay, let me just set notation here. So probability of getting these 3. And what is the probability of getting head, head, tail in this experiment? 1/8, right? It's always 1/8. The probability of getting head, tail, head is also 1/8. The probability of getting tail, head, head is also 1/8. Now, does anyone have any question how we have 1/8 here? Okay, so if you are finding the probability of getting this outcome, you check how many outcome of this type do we have in our space, and we only have 1 outcome here. Okay, and you divide 1 by the total number of sample point. We have 1, 2, 3, 4, 5, 6, 7, 8 sample points. So 1/8 is the probability of getting head, head, tail, and sum of these is the probability of getting 2 head, which is 3/8 is the probability of getting 2 head when we throw when we toss 3 coin. Okay, does anyone have any question up to here? Okay, now let's go to the next one. Okay, now the next we have an event. An event is a specific collection of a sample point. If you collect all sample point, that is a sample space. Okay, and out of all sample point, if we collect very specific sample points, that is our event. Okay, like the one we had in our set A. So our set A is the collection of what kind of sample point? This one. So we have a set A, 2, 4, 6, and this is the what kind of sample points are 2, 4, 6? Even, right? So if we are collecting even sample point when we throw a dice, then that collection of specific sample points 2, 4, 6 is an event. So our set A is an event. Okay. Similarly, if you collect odd sample points, okay, so our event would contain sample point 1, 3, 5. Okay, so event is the specific collection of a sample point. If you collect all sample points, that is your space, that is your sample space. Okay, and from that sample space, if you collect some specific sample point, that makes an event. Okay, let's think. Okay, now if we are collecting a sample point greater than or equals to 4, what will be our event? Let me call that 2. So if we are collecting a sample point which is greater than or equals to 4, if that is the case, our event contains a sample point 4, 5, 6. Okay, 4, 5, 6 is also an event. Okay, so this our A2 set has a sample point which is equals to 4 and greater than 4. Event A is the collection of even sample point. Our A1 event is the collection of odd sample points. Okay, so if you collect very specific sample point from a space, that is always our event. Okay, now here we have an example. Consider the experiment of tossing 2 unbalanced coin. Now unbalanced, now here, so whenever we take balanced coin, the probability is always, the probability of getting head is always 1/2 and probability of getting tail is always 1/2. But if we have an unbalanced coin, the probability is not always 1/2. Okay, so here we have unbalanced coin. Because the coins are not balanced, their outcome, head or tail, are not equiprobable. Okay, the probability of getting head and probability of getting tail is not same if we are using unbalanced coin. Suppose the correct probabilities associated with the sample points are given in the table. So here we have a table, okay, and table has a collection of every sample point. So we have head, 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 tail, tail, head, tail, tail. These are the sample point, and the probability of getting each sample point is also given to us. The probability of getting head, head is 4/9. Probability of getting tail, head is 2/9. Probability of getting tail, head is 2/9, and the probability of getting tail, tail is 1/9. This is given to us. Okay, we have the 2 events. So we have events A and B. Our events A is observe exactly 1 head. Now this is an event. Okay, we have to collect a sample point for each event, and if we once we collect the sample point, it's gonna be easier for us to find the probability. Now what are the sample point for this specific event? So you must collect a sample point where you observe exactly 1 head. Now what are the sample points here for event A? Head, tail, tail, head, right? We have exactly 1 head in both of these sample point. Okay, so these are the sample point for our event A. Now let's make a list of our event B. Event B observe at least 1 head. Now can you tell me the sample point where you see at least 1 head? So what will be those sample points? Head, 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 tail, tail, head. Okay, so we want a sample point that has at least 1 head. Okay, head, head, it has a 2 head. We only want 1 head. Okay, but it has 2. That's okay for us. And head, tail has a head, tail, head has a head. Okay, so these are the sample point for our event B. Any question in listing a sample point for event here? Now the next, we find the probability of getting event A and probability of event B. Okay, so probability of A, this is P of A. Okay, so which is same as probability of getting head, tail, tail, head. Okay, our event A is head, tail, tail, head. That's what I have here. okay, and sum of probabilities of getting these two outcomes is the probability of event A. So this is probability of getting head tail plus probability of getting tail head, probability of getting tail head. And what is the probability of getting head tail from the table? Head tail is 2/9 plus probability of getting tail head is 2/9, and this is 4/9 is the probability of getting event A. Now in the similar way, I want you to find probability of getting event B. I want you to find P of P. Can you find P of P, probability of getting event B? And if you need help, let me know, okay? Find probability of observing at least one head. Does anyone need help here? If you already have an answer. 8, 9. Okay. If you have something different at 8, 9, let me help you. So every time if you are asked to find the probability of getting event, you have to make a list of a sample point for that event, okay? And that will help you. So here we are trying to find probability of getting event B, okay? And event B has this sample point 3, okay? So let me write down this. It's same as probability of getting head, tail, head, okay? And this is sum of probability of getting head plus probability of head tail plus probability of tail head. And from the table, probability of head is 4/9, and this is 2/9. Probability of getting tail head is 2/9, and which is 8/9. Okay, if you are asked, okay, now for example, we have an event C. Okay, observe no head. Now what will be the sample point for this event? You observe no head. Tail is the sample point. Okay, and if we are asked to find the probability of this event C, then this is probability of getting tail. And what is this probability of getting tail? 1/9, okay, 1/9. So every time if you are finding a probability of any event, you have to have the sample point on that event, okay? Then only you can find the probability. Okay, does anyone have any question here? Okay, now we already did an example. Now we have a definition of probability of an event here. Probability of an event A is calculated by summing the probabilities of the sample points in the sample space A. Okay, so here this is our event A, okay, and the probability of our event A is the sum of probability of getting each sample point. Okay, so every time if you are finding the probability of an event, you make a list of a sample point for that event, then you add the probability of getting each sample point on that event, okay, like here. So we added probability of getting head, tail, and probability of getting tail head, okay? So this is how we find the probability of an event. You are adding probability of getting sample point in that event A. Now we have a general step of calculating probabilities of event. So first we define an experiment, okay, that is describing the process. The next we make a list of a sample point. Then we assign probabilities to the sample point, okay, and then we collect the sample point in the event, and at the end we add the probabilities of each sample point. you define an experiment, make a list of every outcome. Okay, it means you construct your sample space, and once you have a sample space, you find the probability of getting each sample point. Okay, and once you have that, you collect every sample point in specific event. Okay, and once you have the event defined, the sum of the sample point of that event is the probability of an event. And here we have an example. Okay, before this example, let's do some example from our activity. So I have this class activity, and this is for chapter 3. Okay, so I want you to try 1 and 2 here. And this will be graded once you complete. Once we complete chapter 3, you can upload it. Okay, you are not required to upload for every section. So I want you to try 1 and 2. If you, okay, I'm not sure you are familiar with the deck of cards. Okay, if you need help with that, let me know. Okay. So in number 1, use our deck of cards. Calculate the probabilities of drawing red cards. Now, do you all know the total number of cards in a deck? How many? What number of cards do we see? Do we have 52? Okay, so 52 is the total number of cards. Now, out of that 52, how many cards are red? Have you counted the red cards out of that 52? The half is red, right? So 26 is the total number of red cards. So what will be the probability of getting one card then? Like for example, if what is the probability of getting 4 of heart? What will be that probability? 1 out of 1 over 52, right? Okay. But you are asked to find probability of drawing red cards. Now, in this, what is the experiment at first? So, for this example, what is the experiment? What do you think? Drawing a card, right? Drawing a card from a deck is an experiment. Now, what are the possible sample points for this experiment? How many sample points do we have for this experiment? So we have a deck of a card, right? And how many cards do we have? 52, right? All those are different, right? They are unique, right? So we have 52 sample points. I mean, you don't need to list all those 52, okay? So, but you can just do that on your head. So we have 52 sample points, okay? Now, our event is drawing a red card. Now, we all know that each sample point has a probability. What is the probability of each sample point? So we have a 52 sample point. What will be the probability of getting each sample point? It is always 1 over 52, right? Like probability of getting diamond of 1, that is always 1 over 52. Okay, king of heart, that is also 1 over 52. Our event is drawing a red card. Now, what are the sample points for this event? Now, you don't need to make a list, but tell me the total number of sample points we have for this event. We have the 26 event, right? Sorry, we have a 26 sample point, right? Is that true that we have 26 red cards? Okay. Now, what will be the probability of drawing that 26 red card? It will be, so you have a 26 sample point, and you are adding the probability of each sample point. Each sample point has a probability 1 over 52, right? You are adding 1 over 52 26 times. And what is that equals to? So you have a 1 over 52 plus 1 over 52 26 times. That is equals to 26 over 52, right? And what is that? 1/2. Okay. I want you to complete 1 and 2, okay? And if you need any help, we'll do that tomorrow. So let's do this much for today. The remaining part, this last example for this, we do have few more topic. Okay, we'll complete this in our tomorrow's class.